We have basically built a dialogue-based, an end-to-end dialogue-based chatbot. This is a goal-oriented dialogue system, and the goal that we are focusing on is to enable the user with the Spotify link by recommending the songs that is based on the user input that has been given to us. So we have already trained our model before. We'll be interacting with the chatbot right now. So I first just sent in a greeting to the chatbot, and it asked me, "Hello, what can I help you with today?" And I put in an input saying that I want to listen to some music with rap. To which the chatbot replies saying that I'm on it. So here it has now taken the entity genre with the value as rap. And now I just sent in an OK. So the chatbot now responds asking which artist should it be. So say I want to listen to Ed Sheeran. The chatbot now responds asking which track that is it that I'm looking for. I gave in my input for the track that I'm looking for. The next question it asked me is what album would I like to hear? I put in my answer. Now the chatbot is actually it is looking in for some options that it would like to suggest us with. So the chatbot makes an API call to get the artist, genre, album, and the track. Now, if I want to change my option for the request that I'm making to the chatbot and say I want to listen to a song named Blem. So I put in the input saying actually I would prefer Blem. The chatbot then asked me if there's anything else I would like to update. I put in the artist that I would like to hear the song from. So I put in um, instead I would like the artist to be Drake Moore. The chatbot now asks me if there's anything else I would like to update on top of this. So I mentioned the album that I would like the song, I would like the track to be returned from. So I say instead I would like it to be from the album called Live. Chatbot again asks me if there's anything else I'd like to update. I say maybe I would like to update something else. It now asks me if there's any preference of genre that I would like to update my input with. So say I want to listen to hip hop. The chatbot now asks me if there is anything else that I would like to update. I say no. And now the chatbot is actually looking for some options depending on the new input that I've fed to the chatbot. So I reply, I wait for the chatbot to reply. So the chatbot now makes the API call. I reply to the chatbot saying that I'm waiting for a response. Now the chatbot actually fetches the URL, the Spotify URL of the album and the track that I have asked for. And it asks me if what do I think about this particular URL. So I say that this one works perfectly fine. The chatbot says great. I say thanks to the chatbot. It asks me if there's anything else that it can help me with, and I say no, thank you, and it replies back saying you're welcome. So this is basically the entire episode of me interacting with the chatbot and giving it my input as to what kind of music that I would like to hear, and the chatbot now replies back with the Spotify link to that particular song. If we actually check out this link, it will take us to the Spotify page. So this is basically the album that I was looking for and this track blend that I was asking the chatbot to return me the link to. So now talking about the approach that we took for building this chatbot. So basically, we refer to a couple of papers and also a code base for MEM networks that was available for dialogue-based chatbot system. So we have basically explained our entire workflow in this particular chart. So to give an overview, the blue boxes are basically our contribution to the existing MEM network model for end-to-end dialogue dataset. And the red blocks are basically the existing MEM network code base for dialogue systems, the components that we have kind of leveraged to build our system. So let me first talk about the data preparation part. So we basically, the code base that is available uses BABI6 dialog dataset. So we have used this dataset as the base reference for building our dataset. Now we created our own dataset for training using Spotify Music API, which fetches us the albums and tracks and genres and artists. The other aspect of this um, basic HCM end-to-end dialogue system is that we need a knowledge base which can be used as a lookup. So we create this data, we create this knowledge base by using the Spotify API. Coming to the part of the HCN, that is the hybrid code network. So basically, first we created our own entities for our specific domain. That is for Spotify, we needed 4 entities for artist, genre, album, and track to give the recommendation according to the user input. We leveraged the entity extraction functions from the existing BABI dataset. But using a certain level of knowledge from this particular function, we built our context feature extraction for entities and actions that will be further fed to the LSTM. Now for the action mask, we try to correlate the action mask dictionary logic with respect to the existing BABI dataset. And we use this to actually build our own logic of action mask dictionary, which consists of unique action templates. And this was specific to our particular domain, and the logic consisted of how the bot would respond according to the user input and what action it would choose. The next component was the LSTM. So for the LSTM, we use the existing model that is there for the dialogue based system. We noticed that this LSTM model works best for goal-oriented dialogue-based chatbots. For the training part, we used our own splitting parameters for the training and development data set. We also tuned parameters such as the accuracy threshold for saving the checkpoints and the number of epochs. And there were a number of trial and errors that we went through to actually come to an accuracy of 95.8%. So basically, all these blue blocks are the contribution that we have done to the while creating the Spotify chatbot by leveraging the red blocks. That is the existing data set that is already available, the data set and the code base that is already available.